Hello YouTube, how's it going? Let's take a quick look at some tests for the things we did in the last episode. So let's start in the utilities where we added we added two functions actually, index and the row column thing. So I just want to test that that index is correct for, let's just call it that. And well, we cannot call it that, I guess, but let's take the index of 5, 4. So that should be equal to something like 4 rows up, 3 columns, something like this, I guess. We run it and it was fine. And now we want to check out of bounds. So if we have like -1, 4, then we want result to be none. If we have 9, 3, 9, 2, I mean, then again it should be none. Let's run that. Again, very happy. And now let's test this one. Actually, something we can do is just like test that if we go back and forth, it's fine. It's the same. So let's say the row is this, the column is this. Then we have the index is this. And we're going to unwrap it because it should give something. And then we can get the let's say new row, new column back by calling this function, the index. And finally, we just assert that it's the same as we started with. And again, that was correct. So I think that's enough for that. Now we also added some functionality in here. Right. We have this take en passant. Principle also has pawn, I guess we could test. And then we have this big move function. Let me zoom out a little bit. Let's check down here in the tests. Okay, for some reason I put the test here, but okay, good enough. Let me just check how many. We have a move piece here. We have a few tests for this move piece, and it's also kind of indirectly tested through the move generation test. So let's say that that's good enough. And we can just add a quick test for this. Where we add a pawn at, say, f7, and we add a king at g2, And then we can just assert that it has a pawn on. Now I have to think. So the row should be, so H is 8, so 6 and 7. And it should not have a pawn on 7, 2. Let's run that. And it failed. Wonder why it failed. So okay, it doesn't. So it could just be that I typed it. I did it wrong. How about this one? We don't really want the index. This is very strange. Let me just check A, B, C, D, E, F. That is indeed 6. And let me check the has pawn function. I'm just going to do some print debugging. So we get into that place. How about here? Or let's print what's on this square. Let's print the square, I mean. So it's occupied, it's pointing to 1. That's kind of weird. Of course, there's always a... Okay, so it's empty. The first one is empty. The first time we called it is empty. Let's bit scan it. That'll give us an index, and then let's get the row and column. We also usually need parentheses. Oops. Okay, so I switched it around, and then it shouldn't be 7, 6, it should be row 2 and column 7. Now it's okay. Let's get rid of that. Let's get rid of the other print, and everything is okay. Let me just, so now we should test this take en passant. So I guess we can just take this. So now we get a position we know has the ampersand set, and then we just want to say take ampersand, and we want the piece on d4 and, or rather c4, and it should take to d3. And now it should not panic first of all. And then we can do something like then we can try to count the pieces that are alive by saying something like filter the piece if piece alive and count that. And that alive count should then be 1. And so it's a piece position and position to, where's that even defined? Here it is. It's a U size. So yeah, okay. So we actually need to do this. Why is it overflowing? Okay, that shouldn't overflow. Let's try this again. 19. It's very weird. What if we move the cast in here? Those are just warnings. No, still panics. Okay. That's very funny. Now I get it. Maybe. Let's see. So we take 2 positions, and yeah, this is the problem. So there's nothing wrong with this. We can keep that, but this should just be new position. And this is correct. Let's try to run that. Okay. Now it panicked. Over here, second square. So again, it's a little bit annoying that I made those mistakes. Okay, now everything seems to work. So then we also need, what is the, okay, just the right should panic. So now we should test that you cannot take en passant when you shouldn't be able to. Cannot take en passant, whatever. I'm always bad at test names. So we can do this again. And this again, I guess. But this time we want to try to take en passant like b3 or whatever. So this should panic. And that also worked. Still annoying that it writes the panic messages here, but whatever. Okay, now here we will have a lot of tests that fail, I thought. Why did I think that? It's because we always have these OR statements, I guess. Well, should clean it up. So let's say alive count is position.pieces, iterate, filter, get the alive pieces, and count them. And now we can actually say that the piece's length should always be, in this case, 2. Still okay. And we could keep doing that, but I don't want to do it right now. I just want to write a quick test for the pawn moves. Don't know why I wanted to look at it as well, but now we have it on the right. So generate pawn moves. Let's make a game. Let's add a pawn on d5. Why not? Let's add it on d2, and then we will say expected positions should be d3 and d4. And then we have this pattern here we keep doing. And then we will generate the pawn moves. We will loop over positions. We will check that the expected positions contains the bit scan of, so very similar to before all the other times. Run it. Did not like that because it is not game.positions, it's this. And it failed. That's amazing. That's very interesting. It is very interesting. So let's first assert here. And yeah, so it's missing a position. I wonder what it thinks the row is. Thinks the row is 1. What does it think the column is? 3. Ah, okay, so important thing to remember is to add 1. So let's actually use the utility function we wrote where we don't forget that. And probably have to import that here. Oh, let's run it. Now it works. Fantastic. See, it's always good with tests. You think you don't need a test because it's so simple, but you usually find something. And now let's test a case where en passant is possible. So I'm going to cheat again, and I'm going to use this example. So we add also a pawn, then we move piece, and now I want to move the black pawn instead, so we are going to say that the expected position is at d3, but also c3. And run it. And we have to call on position. And just make it mutable. Very interesting. So it's something wrong with the interface that we need to think about. Okay. And it seems that why did pawn moves. Okay. Right, so this was a bug I noticed after I made the last video, that we just always try to take en passant. So let's first do this check. Wait a second. So this has to be bit scanned. And with that, we just want to try, so we can take en passant on this square. So that means that we want to check like if row plus direction equals the en passant row, and column minus the column, the absolute value equals 1, so it's like either plus or minus 1. Then we want to do all of this. Otherwise not. Oh, what the... Not sure what I did there. So anyway, let's run it. Still failed. Let me check here. So should go in here, right? EP row, EP call. Three, 4. Is that correct? It should be on D3. So that is indeed row number 3, and so sure that's correct. But it fails. And it fails because of something which we will soon find out. (19 and 18). Okay, that makes a lot of sense. Am I moving the right piece? Ah, now I see the problem. It's because of this. Okay, fantastic. So we just had to assert on the correct piece and not the wrong piece. So here we go, all the tests pass. And we can do a final one where we just have a pawn at like a random place in the middle of the board. D4 should only be 1, D5, and there we go. Okay, so now we added the test we were missing from last time. I think that's it for now. Until next time.